Gas tungsten arc welding course, Gary A. Pace, PECWI. Module 1, Part B, Welding Safety, Safe Practices for Welding. Welding safety. Anytime you're going to do any type of welding, you're going to have some safety involved. There's a lot of ways that things can go sideways with burns, arc flashes, welding fumes, and whatnot. So there's a lot of issues in regards to safety in welding that we need to really discuss. Okay, one of the first items that we really need to talk about is, well, the learning objectives here. We're going to have an introduction we just did. We're going to talk about safety in welding and cutting and allied processes. We're going to talk about arc welding hazards, welding and cutting, and protective clothing, along with a number of other um, issues involved in welding safety or points. ANSI Z49.1 Safety in Welding, Cutting, and Allied Processes. This is a document that's put out by the American Welding Society. If you Google this, you can download a copy. It outlines the safe practices for welding and cutting operations. Almost every welding code is going to kick this out, especially the American Welding Society codes, D11 and other welding codes. They're going to reference this code, this document. Um, when the code is mandated by contracts or law, this one's almost always invoked. And I'm not going to dig too deep into it, but this is this is probably the most comprehensive document in North America on safety in welding, cutting, and allied processes. The American Welding Society puts this out. They put a lot of time and money into it, but you can download a free copy of it if you're interested in reading the whole document. Protecting workers when performing welding operation depends on understanding the hazards involved and the proper way to control them. Controlling welding hazards includes avoiding eye injury, respiratory protection, ventilation of the work area, protective clothing, and having safe equipment to use. There's probably some other items on there, but these are the main ones. Protecting the worker while welding, because there's so many different hazards out there that could cause you bodily harm and you might not recover from it. So might have a permanent impact on your life. So protecting the workers is very important, and we need to understand what safeguards we need to do that. Well, to do that, we need to look at some of the hazards. Arc radiation, UV damage to the skin and eyes. Electrical shock, welding voltages are generally safe, but anomalous conditions can arise. There's situations that could arise where you could get zapped or electrocuted. We need to understand that we're working with electricity and we need to be careful. Fumes and gases, depending on where you're welding, how you're welding, what materials you're welding on, you could end up with suffocation or long-term issues from breathing of the fume. Compressed gases, if you Google Mythbusters and compressed gas cylinders, they launch one of these things through a cinder block wall. So cylinders, we use them all the time, but it's a compressed gas, and we need to realize that, these things could turn into a projectile and punch a hole in the side of a car or, you know, slam into a grade school or whatever. But you understand what I'm getting at. We need compressed gas safety is a major component of being a welder. We need to understand what we're working with. Burns, it's hot metal. You're taking materials up to 3,000 degrees or so and then cooling it back down. Well, even at 300 or 400 degrees, which is the temperature of your oven, your skin touches that material, it's going to burn. So we could have damage done to our skin. And then, fire. We're welding, there could be an issue where we catch something on fire, which we try not to do, but we need to realize that it's a possibility. When welding and cutting is being done, three major safety hazards must be considered and adequate precautions taken. First, The eyes and exposed skin must be protected from the intense light radiation and the heat of the welding arc and flames. Second, welding, cutting, and grinding operations must be prevented from causing fires. Third, care must be taken in handling welding and cutting containers that have held combustible or toxic materials. Cutting or welding also must be done carefully if materials in the fluxes, coatings, and base materials produce explosive or toxic fumes when heated. So, yeah, sounds like a lot of fun. But no, these are things that we can deal with, and we just have to mitigate and understand what the hazards are before we strike an arc. So, and we need to make preparations and prepare for these hazards, and then we go from there. Welder's protective clothing. It is essential that you wear your work clothes properly. Sparks are very likely to lodge in rolled up sleeves, pockets of clothing, or cuffs of trousers or overalls. Sleeves should be rolled down and the cuffs buttoned. The shirt collar also should be fully buttoned. Trousers should not be cuffed on the outside, and pockets not protected by button down flaps should be eliminated from the front overalls and aprons. All other clothing must be free of oil and grease. Wear high top safety shoes. Low cut shoes are a hazard because sparks and molten metal could lodge in them, especially when you're sitting down. Pretty much covers it all. You want to wear heavy clothing. You don't want your cuffs on your trousers and overalls. You don't want pockets or anywhere where you're going to catch sparks. You want the sparks to hit you and bounce off and go onto the floor is what we're looking for. So that's why we don't want a lot of places where sparks can lodge. Also, you don't want to be soaked in oil and grease when you're welding. This is, you're covered in a combustible liquid, and it's just not going to be a good situation if you do happen to catch on fire. If leather protective clothing is not available, wool garments rather than cotton garments should be worn. Wool does not ignite as readily as cotton, and it affords great protection from changes in temperature. Cotton clothing, if it must be used, should be chemically treated to reduce its flammability. Synthetics fabrics should not be worn. Leather's good, wool's good, cotton's good, but you don't want to be wearing polyester or rayon or any of the other man-made synthetic fabrics, because it's just something that's going to catch on fire. So don't be wearing those types of materials, clothing with those materials. They're not good for welding situations. So here's some ideas for some protective clothing, leather aprons, leg aprons, sleeves, coats, gloves, a cape and bib. Depending on where you're at, the cape and bib is a good one because it gives you protection on your upper body, but it remain in your arms, but it kind of keeps your midsection a little freer, but it also a little cooler. Well, I've used the leather apron a lot of times to keep sparks from hitting my legs and stuff. So I'm kind of a leather apron kind of a guy. I'm a cape and bib and leather apron kind of person, but there's a lot of different directions that you can go with this. Okay, so we have OSHA hazard communication standards. So these are material safety data sheets or just safety data sheets. They've changed them a couple of times. So basically what it's telling us is that employers and employees need to know about work hazards and how to protect themselves so the incidence of illness and injuries due to hazardous chemicals is reduced. If there's something floating around, if there's a material being utilized in your place of work, your employer has to tell you about that material. Some kind of toxic goop or glue or whatever it is, you have the right as a worker to go and ask them, hey, where's the safety data sheet for this specific material? I want to know what I'm working with. That's your right. They are required by law to provide you with that information. They can't just tell you, sorry, dude, you don't need to know what this stuff is. So there's a material safety data sheet, and it's generally most places will have it in like a big yellow book. Well, this also tells if the companies are using it in their facility, then it allows them, if there is some kind of accident or incident, somebody drinks some of this stuff or get it spilled on them, you know what to do. The company knows what to do. Okay, you call the doctor, you wash it off, you do this, you call the poison control center, whatever. There's a protocol there that can be followed for just about every material. So, but that's what we're talking about when we're talking about OSHA's hazard communication standards, material safety data sheets. What is an MS and why do we need it? A material safety data sheet is an important component of product safety and occupational safety and health. The MSDS is a document that is used to provide workers and emergency personnel with procedures for handling or working with a particular substance in a safe manner. The MSDS includes information that for that product, including physical data, melting point, boiling point, flash point, etc., toxicity, health effects, first aid, reactivity, storage, disposal, protective equipment, and spill handling procedures. Once again, if you're working with a specific material and you have questions, ask your boss and say, hey, I want to know what this substance is and I want to look at the MSDS for it or the safety data sheet. Before work begins, MSDSs. Before any work starts, the workers must always read and understand the instructions the manufacturers provide on safe practices for materials and equipment and the material safety data sheets. Manufacturers of welding consumables must, upon request, furnish a material safety data sheet that identifies materials present in their products that have hazardous properties. The MSDS gives the users the OSHA permissible exposure limits. This value is the threshold limit value, TLV, as well as any other type exposure limit used or given by the manufacturer. Radiant energy. Electric arcs as well as gas flames produce ultraviolet and infrared rays, which have a harmful effect on the eyes and skin upon continued or repeated exposure. The usual effects of ultraviolet is to sunburn the surface of the eye, which is painful and disabling but generally temporary. Ultraviolet radiation may also produce the same effects on skin as severe sunburn. Exposure of the skin and eyes to the arc is the same as exposure to the sun. So radiant energy comes off the electric arc. You can get sunburned by this. It can damage your eyes. So that's why you always want to wear, you'll see welders, it'll be 900 degrees outside, and they will wear a long sleeve shirt. And they'll usually have it buttoned up. I worked at one place where the welders would put on sunscreen on the back of their neck because there was kind of some flash that would come off and get them from behind due to the shiny ceilings or whatever. So you just want to have something to soak up that ultraviolet radiation. And this is one way to do it is by wearing heavy clothes, safety glasses, gloves, and generally covering up any kind of open spot on your skin that might be exposed to this. The production of ultraviolet radiation doubles when gas-shielded arc welding is performed. Infrared radiation has the effect of heating the tissue with which it comes in contact. Therefore, if the heat is not sufficient to cause an ordinary thermal burn, the exposure is minimal. Leather and wool clothing is preferable to cotton clothing during gas-shielded arc welding. Cotton clothing disintegrates in 1 or 2 weeks, presumably because the ultraviolet radiation from the arc welding and cutting. I don't know if 1 or 2 weeks, 1 day to 2 weeks, but I wear a lot of cotton and it's generally served me well. I wear leather too. Wool, not so much. It's a little warm, but something to keep in mind. Handling of compressed gases. So compressed gases, these things are under a lot of pressure. And there's a whole universe of handling these things. You know, you don't want to move these bottles without a cart or without having the removable metal cap on there. The cap is on there to protect the valve because if this thing falls over and that valve gets broken off, it'll put one of these cylinders through the wall. Like I said, if you want to Google the Mythbusters, I was going to say Ghostbusters, Mythbusters, they have a special thing rigged up and they launch one of these things through a cinder block wall. And I've heard that multiple times that these things will go through those walls. Employers are responsible for the safe use of compressed gas cylinders and liquid containers and their contents. Compressed gas hazards include oxygen displacement, explosion, and toxic effects, as well as physical hazards of a ruptured cylinder. Employers must evaluate compressed gas hazards and have an emergency response plan that defines procedures and responsibilities to address emergencies. This is from the OSHA fact sheet on compressed gas safety. This is an OSHA thing and a Department of Transportation. There's kind of a little overlap between the two regulatory agencies. I think a lot of the regulatory doctrine comes from, the Department of Transportation, but OSHA also addresses it and is very interested and has a vested interest in, compressed gas safety. Once again, if you do a Google search on compressed gas safety, if you have some issues or questions, there's a lot of material out there that covers it. Fumes and gases are generally a greater concern in arc welding than in oxy-fuel gas welding, cutting, or brazing. Arc welding can generate a larger volume of fume and gas due to the variety of materials that can be involved. Protection from excess exposure can generally be done with ventilation. When exposure will exceed permissible limits with available ventilation, satisfactory respiratory protection shall be used. Protection must also be provided for welding, cutting, and other personnel in the area. So there's different ways that we can address the production of fumes. Ventilation is one of the better ways. Welding outside, or somewhere with a lot of, air movement. I mean, it can kind of mess up your welds. We'll talk about that later, but fume extraction, they've come a long ways with fume extraction where you have these smoke suckers and you put them right over the top of your welding plume, the gases that are coming off your weld, and it'll suck them up right there at the source. So there's a lot of different options here. There's, you can have good ventilation through there, or in some situations, I've worked at a place out on the West Coast, all the welders wore specific welding helmets that had filtered air that came in, and they just plugged a breathable air hose into this, and it would send fresh air into their mask so that they didn't breathe any of these fumes in that could, possibly give them problems later on in their life. Exposure factors. Here's some of the factors that affect welding fumes. The welding rod composition, position of the head. I taught welding in high school for 4 years, and kids want to just get their head right over that welding plume, and you have to tell them, dude, get the hell out of there, because you're just going to breathe so much smoke. It's not going to bother you one day, but if you do this, if you end up doing it for a career, you don't want to be breathing this stuff. Types of ventilation are important. The work area, the background fume level. Is there a bunch of background fumes from other metalworking processes that are, involved in this situation? Design of the welding helmet. Different welding helmets might have a different, ability to send the welding fumes around your head, or maybe there's air coming in from, there's some welding hoods that have like a little belt that goes with them and a hose, and that's got a little filtration system that around your waist. It's like a little backpack, kind of little fanny pack on a belt, but it's got a little battery powered fan, and it filters the air and then sends it up through your helmet, and it's got positive pressure, so there's almost no way that the welding fumes can infiltrate your helmet because there's a flow of air blowing air out the helmet. So base metal and surface conditions. What are you welding on? Is it a cadmium coated or a galvanized material or paint or rust or whatever? These are going to affect your exposure factors. Air movement, once again, it gets back to how much air is moving through where you're welding. You can also see here that like submerged arc welding and TIG welding, laser cutting, resistance welding have the lowest fumes. They're over on the left. The highest fumes, arc gouging, flux core, gas metal arc welding, flame cutting, MIG welding, MMA, I think, is shielded metal arc welding, but I think it's the European acronym. So, but arc gouging, flux core, MIG welding have significantly larger amounts of fumes that they're kicking off than something like submerged arc welding or TIG welding. Metals. Here's some of the metals that show up in our welding fumes: aluminum, antimony, arsenic, beryllium, cadmium, chromium, cobalt, copper, iron, lead, manganese, molybdenum, nickel, silver, tin, titanium, vanadium, and zinc. Some, you look on that list, there's some bad stuff on there. And then we've got some gases that get kicked off. You've got your shielding gases: argon, helium, nitrogen, and CO2, carbon dioxide. But then, once you strike the arc on those shielding gases, you can get nitric oxide, nitrogen dioxide, carbon monoxide, ozone, phosgene, hydrogen fluoride, and carbon dioxide. So there's a lot of nasty stuff in a welding plume, in the weld fume. So you generally don't want to breathe that stuff, but we need to be cognizant of what's in there. And this is some of the stuff that can be in there. Electric shock. Electric shock is a peril associated with electrical resistance and electric arc welding. A shock can happen because the equipment isn't properly grounded. Direct contact with energized leads or from contact with the welding leads via moist gloves or clothing, damp floors, or humid air. Even though welding generally uses low voltage, there's still a danger of electric shock. The environmental conditions of the welder, such as wet or cramped spaces, may make the likelihood of shock greater. Falls and other accidents can result from even a small shock. Brain damage and death can result from a large shock. So we need to be aware of electrical shock. If you're damp clothing, wet gloves, welding in water, these are all things that we need to avoid and not do to stay safe in our workplace. Electric shock can cause severe pain, damage to the nerves, muscles, or tissues, internal bleeding, loss of muscle control and coordination, and cardiac arrest. Okay, how are we going to avoid any of these issues? We're going to wear dry welding gloves, wear good insulating shoes or boots, wear protective clothing, avoid contact with bare skin. Always check the welding equipment, in particular the welding cables and the electrode holder, and to repair or replace them immediately in case of damage. The piece being welded and the frame of all electrically powered machines must be grounded. The insulation on the electrode holders and electrode cables should be kept in dry and good condition. Electrodes should not be changed with bare hands, wet gloves, or while standing on wet floors or grounded surfaces. A lot of this is just common sense, but we need to address it. If you got wet clothing, you're working in water, your electrical cables should be kept in a good and dry condition. So this addresses quite a few of the items that we really need to be cognizant of when welding, and the electrical hazards that can come with welding. So